Hello, everyone. Today we'll go over some oxygen cylinder duration calculations, as well as a couple of liquid oxygen calculations and some Heliox flow conversions. You'll find this to be helpful probably in the upcoming exam, but also as you're studying and preparing for the TMC that you'll take from the NDRC. I think that you'll find that's pretty helpful. So these are some common calculations that we'll encounter in the future as respiratory therapy. The liquid oxygen stuff may be more so if you find yourself working at a home care company. And they've got charts built up as far as cylinder duration calculated for home care or sending the patient via ambulance with oxygen. It'd be nice to have the ability to calculate how long that's going to last for you. So what we'll do is we'll go ahead and get started. We'll transition through each one of these and we'll go over a few things as we get to it. So the first thing I want to make mention when you're looking at the cylinder duration calculation, you've got what's called a cylinder factor. The two primary cylinders that we'll work with to handle respiratory therapy are the E cylinder and the H or K cylinder. The cylinder factor for the E cylinder is, so your E cylinder is a 0.28 factor, and your cylinder factor for your H or K cylinder is 3.14. Remember, H or K is pi, maybe that'll help you out a little bit with that. 3.14 is what you're going to utilize. Also, it's helpful to know the formula for doing this. You're going to take your cylinder pressure or your gauge pressure, multiply that by your cylinder factor, and then divide that by your liter flow. And that'll be whatever you may have your nasal cannula or oxygen delivery device set on. So if we look at this particular question, we've got gauge reading 1500 psi, and it's a K cylinder. So now I'm going to multiply that by 3.14, plugging that into the formula. And then I'll divide all of that by 3 liters, because that's how fast we're running the flow rate from that. So go through and do 1500 times 3.14, and that's going to be 4,710 divided by 3 liters per minute. Take 4,710, divide that by 3, that's going to give you 1,570 minutes. Your answer should be in hours and minutes. So now you're going to take 1570, divide that by 60, and that'll give you 26 hours and 10 minutes. So the answer is 26 hours and 10 minutes. Now, if you're doing this on a calculator and you take 1570 and divide that by 3, that's going to give you 26.17 hours. So now all you've got to do is take 0.17, multiply that by 60, and that also will let you know that you've got 10 minutes left. So 26 hours and 10 minutes is the correct answer for this type of question. Clear that and move on to the next. So a little something we've got different here. It's essentially the same question, but a little bit, so we're utilizing the same cylinder factor and the same formula. But we can see that it says that we're wanting to run the K cylinder with a gauge reading 1500 psi to flow rate of 3 liters per minute until that has 500 psi left. So now all you've got to do is take 1500 initially and subtract from that 500. So we know that we're going to be looking for our duration to 1000 psi essentially. So take 1000 and plug that into your formula. Divide that by 3 liters. So this becomes 3,140 divided by 3. That's going to give us 1,046.67 minutes. And you want to divide that by 60, and that'll give you 17.44 hours. And to separate that out, you can take the 0.44, multiply that by 60. That'll let you know that you've got 26 minutes. So 17 hours and 26 minutes. 17 hours and 26 minutes. Or you can do long division in 1046 divided by 60. 17 times, that becomes 1020 with a remainder of 20. You have the 0.67 before. Leave that 17 hours and excuse me, so this turned out to be 26. So 17 hours and 26 minutes. 17 hours and 26 minutes is what you've got for that particular calculation. Next one, we're going to look at an E cylinder. So same formula. It'll be the same formula, but instead of using 3.14, because we've got an E cylinder, we're now going to plug in 0.28. So if it's a cylinder at 2100 PSI, we're going to multiply that by 0.28. We'll set that all over our flow rate of 2 liters per minute. So 2100 times 0.28 equals 7500. We'll divide that by 2, and that's going to give me 3,750 minutes. I want to break that down into hours and minutes, so I'll divide that by 60, and that gives me 62.5 hours. And if you know half, so it'll let you know that it's 62 hours and 30 minutes. Or you can take 0.5 and multiply that by 60. And that equals 30, letting you know how many minutes you have left. Or you can take 3750, do that long division, divide that by 60, and that becomes 62 minus 3720. And you have a remainder of 30 left over. So 62 hours and 30 minutes are left over for that. So the same scenario here as we had with the K cylinder. We're still working with an E cylinder, so we'll still utilize the cylinder factor of 0.28. But now what we'll do is we'll take 2100 and we'll subtract 400 from 2100, leaving us with 1700 PSI. So 1700 is now the number that we'll plug into our formula. So 1700 times 0.28 all over 4 liters per minute. 1700 times 0.28 ends up being 476, and then we're going to divide that by 4. So 476 divided by 4 equals 119 minutes. You should be able to do this, and so you know 60 hours makes up, or 60 minutes makes up an hour. So you don't have quite your 1 minute shy of having 2 full hours. So this would be 1 hour and 59 minutes. But again, take 119 and divide that by 60. And you know that gives you 1.98 hours. 0.98. You know, this would give you 1 remainder 59. Or take 0.98, multiply that by 60. And that's going to give you your 58.8 if you do that, round up to 59 minutes. So 1 hour and 59 minutes would be how you go about calculating this particular cylinder duration calculation. So we'll move on to liquid oxygen stuff. So a few things we want to cover with liquid oxygen, a couple of things that's going to be important for us to understand is when we look at liquid oxygen, we have 1 liter of liquid O2 weighs 2.5 pounds. We also need to understand that 1 liter of liquid O2 puts off 860 liters of gaseous O2. So you can see that you can store a whole lot more oxygen in its liquid form than you could per se in its gaseous form. So now what we'll look at is taking the, so now what you got to do in order to, so you got 2 pounds of liquid oxygen in a liquid oxygen cylinder at a flow rate of 2 liters. How long is it going to last? So now you take your weight and divide that by the 2.5. And that equals 0.8. Now take 0.8 and multiply that by 860, because this is going to convert us from liters to our gaseous form, so we can do our calculation to find out how many hours and minutes it's going to be. So 0.8 times 860 ends up being 688 liters. Then you divide that by 2 liters per minute. When you do that, the liters are going to cancel, leaving you with minutes. So this is 344 minutes. Divide that by 60, and that gives you 5.73 hours. If you did this, that would 5, that would be 300, that leaves you the remainder of 44. So it's 5 hours and 44 minutes. Or you take the 0.73, multiply that by 60. And that's also going to let you know that you've got 44 minutes left over. So that's how you go about utilizing your calculating your liquid oxygen. We've got a couple more that we work on and we'll finish this series of calculations. Patients using 2 liters of oxygen, how long will 3 pounds of oxygen last them? So just like we did earlier, we can take our weight, 3, divide that by 2.5, because those are known variables that we know about. When we do this, this is going to equal 1.2. Then you got to take that, multiply it by your 860. That gives us 1,032 liters. Divide that by the flow rate of 2 liters per minute, and that means that it's 516 minutes. 516 minutes. You divide that by 60, and it comes out to 8.6 hours. 0.6 times 60 is going to give us 36 minutes. So it'll be 8 hours and 36 minutes. You can also figure this out, because if you're looking at 860 liters and 2.5 pounds, so if you were to do so if you were to figure out 860 divided by 2.5, you're going to find that comes up to 344, which would be a conversion from, that would be your number of conversion from liquid oxygen to gaseous oxygen. So if you're going to do that, then now at this point, all you've got to do is take 344, multiply that by the weight of oxygen, which is 3 pounds, and then divide by your liter flow. So if you were to work out 344 times 3, that ends up being 1032 divided by 2. That gives you 516. So it comes out the same way as what we've done. So what I did on the last one is a little bit longer route, but this shorter route may help you out some as well. You take 344, multiply that by your liquid oxygen weight, and then divide that by 2. You should find that works pretty well also. We've got 3 more calculations we'll go over. Those are Heliox calculations. These might show up on the form of a board question of some sort. So To start off with, it's relatively easy, so we won't take a whole lot of time to go through it. But you want to realize that with Heliox, you've got an 80-20 mixture, you've got a 70-30 mixture, and you got a 60-40 mixture. Those have a flow conversion factor. 80-20 is 1.8, 70-30 is 1.6, and 60-40 is 1.4. Typically, all you've got to do is take your flow times your factor, and that gives you your actual flow. So in this question, 70-30 is running at 4 liters. What's the actual flow rate? What's the actual flow rate of the gas mixture? So we know we got a 70-30, so we're going to utilize 1.6. We've got 4, multiply that by 1.6, and that equals 6.4 liters per minute is the actual flow rate through that. So easy enough, but if you've never seen that before, when you get to that type of a question on the board exam, that can stump you a little bit. So we'll go ahead and clear that, move on to the next one. 80-20 mixture running at 70 liters. So an 80-20 mixture is going to be 1.8. So you're going to take 7 times 1.8. Your total flow is 12.6 liters per minute. Again, easy enough, but again, it's one of those recall kind of things. But if you don't recall the information when you get to that exam, it's going to be a little bit difficult to answer that type of question. And then last but not least, we've got an oxygen flow meter is used to deliver 14 liters per minute of a 60-40 mixture in order to achieve an actual flow of 14 liters. What does the flow rate on the flow meter need to be set at? So in the previous examples, we've just tried to determine what the actual flow was. So we multiplied our flow factor by the actual amount of flow. So we're just going to have to work backwards with this. So first off, we need to recognize that we're utilizing 60-40 mixture. So it's 1.4. It's a 60-40 mixture of 1.4. What we're going to do now is take 14, divide that by 1.4. And that's going to let me know what the flow meter setting is. So 14 divided by 1.4 is 10 liters per minute. So if the actual flow is 14 liters per minute with a 60-40, if the actual flow is 14, if the actual flow is 14 liters per minute, I need to know what the flow rate on the flow meter needs to be set at, so you can just work in reverse. Knowing that your factor is 1.4, take 14, divide that by 1.4, that gives you 10 liters. I hope you found this to be helpful. I'll try to come up with a few more things later on in the future. Thank you all for your time and attendance, and I hope you have a great day.